We are in class 12th subject physics. Today we are going to discuss the topic. It is cyclotron, right? This is the third unit, magnetic effects of current and magnetism. So today's topic is cyclotron. Let's have an introduction regarding the topic. See, cyclotron. It is a device which is used to accelerate the positively charged particles. Okay. Then those positively charged particles are used in different types of activities like to take the nuclear reaction and etc. Before development of this device, the cyclotron, they are used to be very long type of accelerators which were called as linear accelerators. Okay, so what those linear accelerators were, they were actually very long tubes of the order of hundreds of the feet in length. Okay, but in handling these long tubes, long accelerators, the linear accelerators, people used to face difficulties. Okay, then these two people who developed this accelerator, this cyclotron, they were Lawrence and Livingstone. They came forward and they developed a small type of device which we call as this cyclotron. Okay, now what this cyclotron mean? Let us repeat. Cyclotron, it is a device which is used to accelerate the positively charged particles, right? Then those accelerated positively charged particles, they are used to take different types of activities like nuclear reaction and etc. Right? Now this is the point. It is the principle of the device cyclotron. We should understand on what principle this device works. See, this device, it works on the principle that a positively charged particle can acquire as very high energy, very high kinetic energy, very high speed. Okay, when by applying a small oscillating electric field, okay, the charged particle can gain this speed when this charged particle is repeatedly put in the field again and again in the presence of this magnetic field, right? So this is the principle of this cyclotron. Let me repeat it. It works upon the principle that a positively charged particle can be accelerated to a sufficiently high energy with the help of small values of oscillating electric field by making it to cross the same electric field again and again with the use of strong magnetic field, right? So this was the principle of this cyclotron, which you can find out from the books. The important thing to know regarding it is this construction of this device cyclotron. So now let us understand the construction of this device. See, here it is the total this structure of this cyclotron, but let me take it in parts. This cyclotron, it consists of two semi-cylindrical chamber called as Ds. This is D1, this is the next D. These two, okay. So let me name this D1, this D2. They are two semi-cylindrical chambers which we call as Ds because it is of the shape of D. Because when we cut a cylinder into two halves, we get the shape of D. So we call them as Ds, D1 and D2. They are separated by a little gap. Okay, this is the gap. These two Ds, D1 and D2, they are placed in horizontal level. Okay. Then whole of this system, meaning the D1 and D2, they are placed in say a chamber. They are enclosed by some surface filled by the gas at low pressure. That gas used to be of the order of 10 raised power minus 3 mm. Okay. Then this whole system, it is connected with the electric field, oscillating electric field like this. This is the oscillating electric field, okay, alternating electric field, which provide us it positive and negative halves, as we can understand later on in the activity, in the working of it. Then whole again this system is placed between two strong magnetic poles, north pole and south pole, in order to provide the magnetic field, right? Then the next thing, the charged particles, positively charged particles, which are to be accelerated, the source of those charged particles, it is placed over here, in here. Here, this is the source of the charged particles which we are going to accelerate. Let it be denoted by I. Right? See, this source, this can be this hydrogen gas in order to get protons, because protons are positively charged particles, and for those deuterons, those are also positively charged particles. For that we can use here helium gas. So for proton positive charged particles we use here hydrogen gas, and for that deuteron, okay, we use here helium gas. So here is the source of positively charged particles. So this was all regarding the construction of this cyclotron. Let me repeat it. It consists of two hemi-cylindrical, meaning semi-cylindrical containers, which we call as Ds, D1 and D2, which are kept horizontally. They are separated by some gap, which contains the ion source, the positive charged source in the gap. Let it be denoted by I. These two Ds, they are connected with alternating source, okay, which gives is it the oscillating electric field. These two system of Ds, they are enclosed in a container containing the gas at low pressure. It is only for this low pressure gas is used in order to prevent the leakage of the charged particles, right? Then whole of these D system, it is placed in two strong magnetic fields, magnetic poles, north pole and south pole, right? One of the D, let me this D, it is having a little bit hole which we call as window, right? So this is the window from which the charged particle after accelerating, after acceleration, it comes out. Then when it comes out of this window, it strikes the target to take the reaction. So this was all regarding the construction of this device, cyclotron, right? Now let us have the working and theory of this cyclotron. This is working. See, at the first step, this is the ion source, positively ion source, and it emits the positively charged particle. Let at the first attempt, since these two Ds are connected with oscillating electric field, let this D1, it is positively charged, it is positive and it is negative. At the first half, we know oscillating field means which is having positive, negative, meaning the alternating. Positive in the first half, if this is negative, at the same half, this will be positive. Then it oscillates, meaning the alternating current now changes. It changes it as that it changes the direction, meaning then in the next half, this then becomes positive, it becomes negative, and after that again this becomes negative, this becomes positive. So let us take the first half again. For the first half, let this D2 is negative, right? What happens to this charged particle? Since it is positively charged particle and D2 is at negative potential, this positively charged particle, it will get attracted towards D2. Okay. Now what happens? And it enters this half chamber, meaning the D2. Since there is a magnetic field, and this magnetic field, direction of this magnetic field, it is at normal, meaning at 90 degree to the plane of these Ds, right? And we know when there is a 90 degree magnetic field, normal magnetic field, the charged particle, it will follow the circular path. Then when it is attracted by D2, it enters into it and follows the semicircular path for this time, on the first half of the input AC. Okay. Then in the next half, what will happen? Now this becomes positive and this becomes negative, meaning now this d1 is negative and d2 is positive, and it will get attracted towards d1 now. Okay, but in the gap, what happens? Since there is the application of magnetic field due to this north and south pole, here in the gap, the charged particle, it will get accelerated. Its speed will get increased, because whenever there is an application of the magnetic field, we have understood it in the previous topics, the charged particle, it will get accelerated. Okay, so meaning there will be the increase in the speed within the gap. And important to know, within the D, when the charged particle was in motion, first it followed the circular path, but in the next point, the speed of this charged particle was constant when it was within the D. But when it came out of the D, meaning it reached to the gap, its speed will get accelerated due to the application of this magnetic field. Okay. Now for the next half of this first cycle, now this D2, D1, it becomes now negatively charged, this becomes positively charged, meaning this D2, it is at positive potential, and D1 now comes at the negative potential. So this charged particle now will get attracted towards D1, and with the same fact, it will again follow the semicircular path from this point to this, meaning now this is the completion of one half of input AC. For the next half, the same thing gets repeated, meaning now again this D2, it will reach to negative potential, and this D1, it will reach to positive potential. Due to this negative potential, now this charged particle, it will come again towards this D2 with the same circular path, but in the increasing radius. The circular path will now have the increasing radius. Okay, this will be understood in the theory how and why there is an increase in the radius. Okay, but important to know is that in the gap, again the charged particle will get increase in the speed. So it is clear that in every cycle of this input AC, the charged particle, it will follow a circular path, and after in each cycle, the radius of this circular path goes on increasing, right? But this thing is to be happen within the cycle, meaning for the first half of input AC, since this G2 was negatively charged, the time in which the charged particle is to follow the semicircular path should be same in each semicircular path. In order to make it harmonious to the field, to the potential. That is, when the charged particle comes out of D2 in the first half and enters D1 at that time should be negatively at negative potential, and when it covers, when the charged particle covers again the next semicircular path and it enters D2 at the same time, now again D2, it should now be at negative potential, and this D1 should be at positive potential. So with each half of this input AC, the charged particle should cover the semicircular path within the same time in which the input AC, the oscillating that field reverses its direction. Okay. Again, we understood that there is an increase in radius of the circular path, okay, of the charged particle, but the time is the same, constant, meaning that it is that time for which the oscillating applied electric field, it will reverse its direction. So we understood here that the time is constant. Okay, and we can understand it in the theory when we go to mathematical aspect also. So when the constant time is same, so for the first half, let it be the smaller radius, meaning the smaller distance, and in the next half, that distance to be covered by the charged particle, it is more, and in the third half, it is again more than the more. Okay, so in each half, remove half of the cycle of this trajectory of this path, the radius increases, meaning the distance increases, but the time is constant. So it is clear that particle is to have increased its speed. Okay, so at each step, at each semicircle, there is an increase in speed of the charged particle. So after very lot of these circular paths, there is increase in the speed of the charged particle at each step, and when it comes out of the window, its speed is very high, and then with that high speed, meaning the accelerating speed, it strikes the target to take the reaction, right? Now this is the theory of this whole activity. First one, we understood that there are two sorts of the forces. First force on the charged particle is due to the magnetic field. Okay, this is the force due to magnetic field, because we have applied north and south magnetic poles, so this will provide the force on the charged particle which is accelerating. That force we know it is the force due to magnetic field. It is equal to QVB sin theta, which we have understood in the previous lectures, and here theta is 90 degrees because the magnetic field is applied normally to the direction of motion, to the plane of motion of the charged particle. So here it is 90 degrees, since sin 90 is equal to 1, so this comes to be QVB. And next one, this force will provide it a centripetal force. It will move in the circular path, and again we know that when the charged particle motion is normal to the application of the magnetic field, the particle follows the circular path, meaning the centripetal force. Okay, centripetal force. While the particles move in the it's in the circular paths, that centripetal force is given by m square by r. These combining the two, meaning, or we say that equating the two, we get this relation. This is the radius. So here is an important thing. Radius is directly proportional to velocity, speed. Because mass, charge and magnetic field, they are constant terms, here v. So with the increase in this speed, the radius increases, which we understood here. At each step, there is an increase in speed of the charged particle when it reaches in the gap, because in the gap there is an increase in speed of the charged particle, and within that is the charged particle move with the constant speed. So here it is clear that whenever there is an increase in speed of the charged particle, its radius goes on increasing. So here it is clear that the increase in the radius of the path is directly proportional to its velocity, its speed, and that increase in the speed is due to the electric field, which we understood in the gap. In the gap, there is an increase in the speed because this d1 and d2 they attract us, the charged particles, due to the applied oscillating electric field, right? Now this is the next point, time for semicircular path. What is the time that it will take for the single semicircular path? And we know speed is equal to distance by time, or we say this time is equal to distance by speed. Simple. And here the distance is the length of this semicircular. For the whole circle we call that as circumference, right? For the whole circle. For the semicircle it will be half means it is pi r, because for whole circumference that is 2 pi r. For semicircle it will be only pi r, meaning the length is pi r divided by speed is v, and we already know this radius in the previous previous topic, that radius is equal to mv by qv. By using this value of r over here, okay, we got this time it is equal to pi m by qv. All these terms are here constant. Pi constant, m, q and v, they are all fixed, meaning the constant, no change in it. So we understood here that time is also the constant, because all these terms, these are the terms, they are constant, because pi is constant, m is the mass of the charged particle, that used to be remain constant, charge of that charged particle is constant, and magnetic field which we apply, it is also constant. So we understood here that the time is constant, which we discussed in the previous discussion, that the time for which it takes a circular path or semicircular path is constant, meaning how much time it will take for this small circle, it will be same for the big circle. So in the big circle, since the time is smaller, because here is the time of 10 raised to power minus 3 seconds, but the distance is low, and at the longer distance, the time is same, but the distance is more with the little time, okay, then particle is to accelerate, because time is constant for smaller semicircle as well as for the larger semicircle. For larger semicircles, the particle is to increase its speed as compared to the smaller semicircles. So this is the time, it's constant. Then what is the time period? Time period is the time for full complete circle. This was for semicircle. Okay, so this is for semicircle. For time period, we know it is for full circle. That will be double of it, because this time is for some half of the circular path. Then for the full circle, we call that as the time period. That will be double of this. So this is the time period, right? Now next it is the frequency. Frequency, we know it is the reverse of the time period. So frequency, no, this nu is equal to 1 by t. By using the value of t, we will get the frequency. So frequency is equal to qb over 2 pi m. Now this is the next point, is energy of accelerated particle. This is the main thing in the topic which we should know. This is the how much is the energy of that charged particle. And here we know, here is the energy is not the heat energy or other sort of energy. This is only the motional energy, meaning the kinetic energy. How fast the particle will come out of the cyclotron, that will decide its energy. So higher the speed, higher the acceleration of this outgoing charged particle, higher will be its energy. Okay, so this energy is totally, it is kinetic energy, and we know kinetic energy is equal to 1 by 2 mv square. And in order to find out the velocity, that we can get from the previous relation of the radius which we took in the first point, then velocity comes to be this. Using this velocity over here, we get energy is equal to 1 over 2 value of v, here value of v square. So this energy, it reaches to be this factor. Here it is important again to know these factors: charge, magnetic field and mass. They are again the constant. Again, this energy is directly proportional to the radius of the circular path and square of the radius. So meaning, higher the radius of this circular path and higher will be the energy of this charged particle. So in order to get the very high speed, high energetic charged particle, it is radius of the circular path is to be increased, which is the important principle in this device. That as there is the increase, as there is the increase in the number of circular motions, the radius goes on increasing, which in turn increases the energy of this charged particle. And as it comes out of the this window, through the window, and strikes the target, it strikes it very, very high, with very, very high kinetic energy. Okay. Now let us discuss some of the limitations of the cyclotron. First limitation is that we observe here that it only is able to accelerate the charged particles. First one, it cannot accelerate the neutral particles. First one, because they will not get attracted due to this d1 and d2. So first one, it cannot accelerate the neutral particles like neutrons and etc. Next one, it cannot accelerate electron. No electron acceleration. No electron acceleration. Why it cannot accelerate the electron? Okay, when it accelerates the proton, deuteron, why not electron? Because that is a charged particle. It is simple that electron is very light, so it can go out of step. Out of step means before the time it can come out of the d. Let us suppose that the time for which the charged particle was to remain in the first d, let it d2 was 10 power minus 3 seconds, for example. But this electron is so light, it will move earlier. It will come earlier out of the this d2 and reach and try to enter this, where there will be the opposition, because the polarity will have not yet been reversed. So it will create the difficulties in the motion of that charged particle. So let me repeat it, that electron cannot be accelerated because it can go out of step, as that is, it can move earlier into the next d, where the charge will be against to it. Okay. And third one is, if the particle will get such a speed that it is comparable to the speed of light, meaning it will move with very high speed, comparable to speed of light. There the theory of relativity acts that with the speed of the particle comparable to the speed of the light, there is increase in the mass. So when it reaches to the speed of the light, okay, there is the relativistic increase in speed in mass of the charged particle, which will now again create the problem in this, in covering the given distance in the given time. So let me repeat it, that the particle which move to the speed, which will reach the speed comparable to the speed of light, that will face again the problems in covering the given distance in the given time. So the limitation of this cyclotron is that it can accelerate the particles with the speed lower than the speed of the light. Right? Thank you. This was all regarding the cyclotron. Assalamu alaikum.